Hello everyone, you're welcome back again. We're going to solve for the value of x from this Olympiad mathematics. And the given equation is 4 to power x plus 4 to power x is equal to 16. Then we are asked to solve for the value of x. If you look at the left hand side of this equation, we are adding the same thing, 4 to power x, 4 to power x. So therefore, 4 to power x is common. So we can factor out 4 to the power of x, then we open bracket. Now we're going to divide. 4 to power x divide 4 to power x. When the same thing divide itself, it becomes 1. Then plus, then 4 to power x divide 4 to power x, we are going to have also 1, which is equal to 16. So when you use this 4 to power x to open this bracket, we are still going to get the left hand side back. So 4 to power x open bracket 1 plus 1 is the same as 2, so everything now will be equal to 16. And remember, we are looking for the value of x, so therefore we eliminate this 2 by dividing both sides of this equation by 2. So we divide the left hand side by 2 and also the right hand side by 2, so that this 2 is going to cancel this 2. In the left hand side, we are left with only 4 to the power of x, which is equal to 16 divided by 2 is the same as 8. Now we have 4 to power x is equal to 8. If you look at this equation, this exponential equation very well, there's no way we can make 8 to be in the base 4. So what we're going to do from here is to apply logarithm. So we're going to take the log of both sides to base 10. So we have log of 4 to power x, which is the same as log of 8. So from here, we recall power property of logarithm. When you have a logarithmic of a term raised to the power of another term, we can take the power back to multiply the log. See, this is one of the property of logarithm. So when this x go back to multiply the log, we are going to have x log 4, which is equal to log of 8. Now, the next thing we're going to do, remember, we are looking for the value of x, is to divide both sides of this equation by the coefficient of x, which is log 4. So we divide the left hand side by log 4 and also the right hand side by log of 4. So that this log 4 is going to cancel this log 4. So in the left hand side, we are left with only x, which is equal to log of 8 divided by log of 4. So this is the value of x, but we are not going to stop at here. We are going to simplify further. So we are going to have x now will be equal to log of 8. This 8 can also be written as 4 multiplied by 2, then all over log of 4. And when you recall multiplication property of logarithm, when you have log, when we have log of a multiplied by b, this is the same as log of a plus log of b. So this is one of the property of logarithm we are going to apply to the numerator in the right hand side, so that we have x now will be equal to log of 4 multiplied by 2. We are going to write it in this form, which is log of 4 then plus log of 2, then everything all over log 4. And one of the property of mathematics, since we have log of 4 is adding to log of 2, and in the denominator we have log of 4. So therefore, these two terms can share. So we have x now will be equal to log of 4 over log of 4, then plus log of 2 over log of 4. So we are going to have x now will be equal to log of 4 divided by log of 4. The same thing divide itself is going to give us 1. Then plus log of 2 over log of this 4 can also be written as 2 raised to the power of 2. So that we have x now will be equal to 1 plus log of 2 over. If you recall the power property of logarithm, this power here can come back to multiply the log. So we're going to have 2 log 2. So we have x now will be equal to 1. X now will be equal to 1 plus, when we factor out, when this log 2 cancel this log 2, so this is going to be 1. So in the numerator, we're going to have 1. So when we factor the 1 out, we're going to have 1 all over this denominator here, which is 2. It's only log 2 and log 2 that cancel. And when the same thing divided is the same as 1. So we just factor out 1 over 2. So that we have x now be equal to, the LCM here is 2, so we just write the LCM as 2. Then 2, this place is the same as 1 over 1. 2 divided by 1 is 2. Then that 2 multiplied by 1 is the same as 2, plus 2 divided by 2 is 1. Then 1 multiplied by 1 is the same as 1. So therefore, x now will be equal to 3 over 2. So therefore, 3 over 2 is the value of x that satisfies the simple Olympiad problem. Thank you for watching, and please follow us for more videos like this. Thanks.